Hi there, this is Math 7, Unit 6, Lesson 19, Expanding and Factoring today. We're going to use the distributive property to write expressions in different ways. So first of all, let's have a little talk about parentheses and kind of order operations. And find the value of each expression mentally. So when I look at this first one, I recognize that I need to do multiplication first. So I'm going to do 3 times 4, which gets me to 12. And then 12 plus 2 gets me to 14. When I look at this one, because I have something inside the parentheses, I'm going to take care of that part first. 2 plus 3 gets me 5, right? And then I can multiply 5 to the 4 to get me with a 20 there. Over here, again, order operation says multiply first, so 3 times 4 is still going to be 12. So then I end up with something that says 2 minus 12. I'm going to rewrite it real quick just so I can take a look at it so I don't get too confused. So 2 minus 12 is like 2, and I'm adding the opposite, negative 12. So I end up at a negative 10 is what I have left there. Here, I'm going to add those together to come up with a 7. So I have 2 minus 7, or I could say 2 adding a negative 7. And so when I put those together, I have a total of negative 5 for my solution there. So it's important to take a look at parentheses and know how order operations work so you know what's going on. Today's lesson here is on factoring and expanding with negative numbers. And it's a really important skill for you to learn how to master and do regularly on your own. And so we have a lot of practice with this today. And this may be the first time you're really seeing this, but the idea is that if we know how to distribute something, that means if we know how to take a negative 3 and multiply it into a 5 minus 2y, when I take this expression right here and I distribute, I do negative 3 times 5, which gives me that negative 15, and a negative 3 times a negative 2y gives me the positive 6y. And so I know that when I put that together, I could rewrite this whole thing as also being negative 15 plus 6y, and these are two equivalent expressions. They're the same thing. I can do it here by practicing with this box here to help me understand, like with the area grid, how this works. 5 times a becomes 5a, right? And 5 times negative 6 is a negative 30. So if I had to write this out over here expanded, this is the expanded way, I would take the 5 times a minus 6 and rewrite this as 5a minus 30, because that's what I see here as expanded. So this way is 5 times what I have right here, a minus 6. And then when I distribute it, I end up expanding and stretching it out. But what's really cool is about going the opposite way. I can do the distributive method in the opposite direction in order to kind of pull things apart. And to do that, what I look at is I look inside the box here and say, well, what do both boxes have in common? We kind of call this a common factor. So in this case, I recognize that they have different letters. I can't do anything about the letters, but I notice that they're both even numbers, a 6 and a negative 2. And so in this case, they've already helped you out by saying I could take a 2 out of each of these. And so to think to yourself, 6 divided by 2 is what? That's going to be 3. I could think the other way and think 2 times what number can get me to 6? Again, it's 2 times 3. The a I don't want to forget about, so I'm going to include it here. And so you can see if I multiply 3a times 2, I end up with 6a. Over here, I'm going to take a 2 out, and so negative 2 divided by 2, negative 2 divided by 2 equals what? It equals a negative 1. I could write a negative 1 right here if it helps you see it better, but I'm also going to keep the b, so I have negative 1b, or just simply negative b. So, as written as a factored way, I have a 2 on the outside. Okay, this is my 6a minus 2b. I have a 2 on the outside, and that's going to multiply together with 3a here, and I can just write minus b right there. So we're going to do this same idea all the way down with all these other ones just to practice it out. If it helps you to write it with the boxes, you certainly can. If you start to see it a little better, that's okay too. So let's talk these through. So I'm going to do the ones that are factored and make them expanded first. So negative 4 times a positive 2w is going to become a negative 8w. Now a negative 4 times a negative 5 is going to be a positive 20, and I include the z, so positive 20z. On the next one, I'm going to distribute the negative. Even though there's not a number there, I can pretend it's like a negative 1 if it helps you kind of visually see it a little better. It's just a negative there. So negative 1 times a 2x becomes a negative 2x, and a negative times a negative 3 becomes a positive 3y. When I look at this one here, now I'm going to have to go the opposite direction. We can distribute backwards a little bit, right? So let's say I take my box like this, and I know I have a 20x, I have a minus 10y, and I have a 15z. What number or letter can I take out of all three of these? And in my case here, I recognize I could probably take a 5 out of everything, because these are all factors of 5. 5 times what gets you to 20? 5 times 4. So we would include the x to make it 4x. 5 times what number gets you to negative 10? That'd be a negative 2, and keep the y with it. And over here, 5 times what gets you to 15? That'd be a positive 3z. So in terms of rewriting this factored, I have a 5 on the outside, and inside the parentheses, I would have this group of numbers. I'd have 4x minus 2y plus 3z. For this one, we're going to expand. K times 4 is 4k, and then k times negative 17 is negative 17k. Could I group them together? Yeah, I could eventually, but right now I just want you to practice expanding and then working the other way. All right, on this one here I have really just two boxes, right? I have 10a and I have a minus 13a. There's no number that goes into both 10 and 13, but they both do have an a, and I could take an a out of that with no problem. If I take an a out, what do I have left? I just have 10. 10 times a is 10a. And over here, what I have left over here, I have a negative 13. So when I rewrite this, I have a on the outside, and what goes inside the parentheses is here, 10 minus 13. So that's the factored way. For this next one, we're going to multiply negative 2x times a 3y for a negative 6xy. And then a negative times a negative is going to be a positive, and this will be a 2xz, like so. On this next one, let's see if I can do without the boxes here with you. They each have a b and a b and a b. They all have the b in common, so I can factor a b out of the whole thing. What's left of this term is an a. What's left here is a minus c. And what's left here is a minus 3d. And finally, this last one, negative x times 3y becomes negative 3xy. Negative x times negative z becomes a positive xz. And negative x times 4w becomes a negative 4xw. Alrighty, and that's it there. So that's the idea between factoring and expanding, and that really is what today's lesson's about, which is take some practice. You will continue to use this skill all the way through the rest of your math classes, all the way through high school. In fact, I just did one of these lessons the other day for a Math 2 course. So, in summary, here's our point today. You can use properties of operations in different ways to rewrite expressions and create equivalent expressions. We can use the distributive property we've already seen to expand an expression, and we can also use distributive property in the other direction to factor an expression out. So it works both ways, right? So we can take something like this as 12x minus 8, and we can factor out. When we take a look at this, we see that what do they both have in common? There's a 4 that they both have in common. I can take a 4 out of there and a 4 out of there. And I ask myself then, 4 times what gets me to 12? 4 times 3. I keep the x with it. And then 4 times what gets me to negative 8? That'd be 4 times a negative 2. So in factored form, this becomes 4 times 3x minus 2. But that is equivalent to this thing, which is 12x minus 8. Those are the same expressions. They are equivalent to one another. And that really is what today's lesson is all about. All right, let's take a look at